So I welcome you all to this third
Good
day of
afternoon, sir.
good afternoon. On this third day of the 5-day FDP, which is going on advanced research methodology. So today we will be discussing on the critical topic of factor analysis, and this will be done using the tool which is called as SPSS. Okay, so before we start with the presentation or before we start with the details on this particular uh, topic, I would like to discuss few basic aspects of the concept of factor analysis. And this is also something related to the basic concepts of research methodology and why the requirement of this factor analysis came into being. Okay, so can anybody tell me what is the meaning of this term factor analysis? Or what is the other name of this term factor analysis? In any one of you? Okay, so basically, the term factor analysis is a term which we use for basically data reduction. Okay, and this technique is also called as data technique reduction technique. Okay, now why do we need this factor analysis, or why do we basically want to understand why that we need this factor analysis? So the prime agenda of this particular workshop is to understand what is the function of factor analysis, what does it do, why do we do so with using SPSS, and what all things we will be able to get when we are doing or learning the factor analysis. Right. So the factor analysis basically as I told you, is a data reduction technique. And when you basically understand, or when you say that it is a data reduction technique, so basically data reduction technique means that whenever you are doing research, and specifically I'm talking about the primary research, you get a lot of factors which are basically contributing to your study or to your variables. Okay, so to your dependent variables specifically. So let's say that you want to understand, or you want to see what are the factors that will lead to uh, increase in the GDP of a particular economy, okay, of a particular country. So there are several factors, or let's say you want to understand what are the factors that will lead to proper work-life balance of a particular individual who is working in an IT sector, or in an education sector. Okay, now there are many factors which basically work there. I generally teach students of PhD also, and I take the example of that. Let's say if a student want to understand that how can I be placed, or how can I basically top a particular set of class. So to understand all these factors, or all these problems, which are also called as problems of the management domain, we basically use this particular concept of factor analysis. Okay, so when you have different factors contributing to a particular, you can say, phenomena, then we need to understand that what are the major factors which are important. Okay, and the reason for understanding these major factors is because ultimately, when you are doing research in the domain of management studies, management domain, or in the commerce, or in the social science domain, basically we want to control the different environment which we are in. Okay, so to control that particular or to basically influence that particular environment, we go for this factor analysis. Okay, we basically go for this data reduction technique. Now, doing this will basically help us to reduce the numerous factors that are leading to a particular phenomena, and which are easy to manage or easy to control. Okay, so that is the only function or only role of doing or undertaking the factor analysis. Okay, so most of the functions, or most of the research which we are doing these days, they generally people, or generally they are you can say differentiated into the exploratory or confirmatory. Okay, so when you are exploring the different kind of factors, or you are basically trying to understand what are the different factors that are leading to a particular phenomena, factor analysis play a very important role. Okay, so while you are doing the factor analysis, there are few very important things which we should understand as a researcher, okay, and which we should basically take care while doing our research. Okay, if I'm not wrong, I have mailed you all the link of SPSS. Okay, and there are two files which are there. One is the Excel sheet which is carrying the data, and another is the questionnaire. Okay, so this is the case of one of my old student, okay, old PhD student, and she did PhD on work-life balance of women in IT sector, and then she basically made a questionnaire out of it, and then that was a primary based study. So she made a questionnaire out of it, and then it was circulated to the respondents, and all these respondents, through these respondents, data was collected, and then it was analyzed through factor analysis.
Sir,
Okay.
are you sharing the sheets, any slides, sir?
No, I'm not sharing any slide, but I have
Okay.
mailed you some PPT. Sorry, this Word file and an Excel file. If you have not received, I will remail it again today. Dr. Monica has shared it with you.
We received one Excel sheet.
One Word file is also there. Okay, if in case you're not having it, I will share it.
Response sheet WLB we have received.
Right. So there is another questionnaire also, Word file. If you have not received it, I will share it again. We will be requiring it tomorrow. Okay, because the hands-on practice will happen tomorrow. So we will basically need to understand what is the problem, okay, first, and then how to solve this particular problem. So I will also be sharing her topic and the objectives, and will show you how it is applicable or how can you do it using factor analysis. Okay, so I was talking about the concept of factor analysis, that we are not able to, or as a social scientist, we are not able to basically control the different functions of factors which are basically contributing to a specific phenomena. For example, there are phenomena like passing a subject, or you can say writing a research paper, okay, or getting a PhD thesis. So all these are different phenomena. So there are various important factors, and out of them, we basically want to get down, or we want to basically get only those factors that are actually very, very strong. Okay, so this factor analysis technique basically join all those functions or all those factors which basically are related to each other or have high correlation among each other, and join them into few factors, or reduce the total number of factors. So we basically get concrete 4-5 factors or 2-3 factors which are very, very important for to achieve that particular phenomenon. So basically, if we can say that this particular technique of data reduction or factor analysis is a parsimonious technique. Okay, parsimonious technique means we are going to have as minimum or as least number of factors as it is possible. The reason is that if we increase the number of factors, okay, then obviously the explanatory power of our model will increase. As we do it in regression also, we do the same thing. A regression also basically is a parsimonious process also, only where we try to for increasing the R square of the model, we keep on adding the variables. But again, we cannot add n number of variables to our model. Okay, because otherwise this will make that particular model spurious. Okay, so we have only few variables which basically we will keep and we can add, and after that we have to put a stop on that particular variable, number of variables. Similarly, in factor analysis also, we basically follow this same psychology or process of parsimonious number of variables, and we try to reduce the number of variables which are basically controlling a particular phenomena. Okay, and therefore we use this particular concept of factor analysis to reduce the number of factors and finally get the desired factors. Okay, so if you talk about or understanding of the factor analysis, so factor analysis is commonly used in number one, data reduction. Second, scale development. Can anybody tell me what is scale development? If any one of you has taken or undertaken a project on scale development or done research on scale development? Yes, anyone? Okay, basically, when you talk about scale development is a procedure where you develop a standardized scale for a particular phenomenon. Okay, for example, I work in the domain of technology or adoption. Okay, so in technology adoption, there are certain scales like and models like UTAUT, technology adoption model TAM. Okay, diffusion of innovation model DOI. Okay, then there are several other scales also or models also. So in social science, basically domain, we try to develop certain scales which are applicable globally. Okay, and the researchers can use those scales, standardized scale, or just reshape those scales and can use them for their own research. Okay, so such scale development is also done through factor analysis. Then the evaluation of psychometric quality of measure and the assessment of the dimensionality of the set of variables. So whenever you are measuring any variable, do you all understand the difference between a variable and a construct? Can anybody explain what is the difference between a variable and a construct? Yes, I can see there are 31 participants.
Sir, a constant has a fixed value, but a value of the variable can be changed.
No, no, I'm not
uh,
talking about a constant. I'm talking about a construct.
Construct.
Hmm.
Okay.
Yeah,
Uh,
one is variable and a combination of variable basically gives you a construct. Okay, so
okay.
there are two aspects of quality of measure and dimensionality of variables, which we will study. Okay, and before we go ahead, we should understand the meaning of the term uh, construct. What is a construct? So regardless of the purpose, factor analysis is used in determination of small number of factors based on a particular number of interrelated quantitative variables. Okay, so unlike variables directly measured such as speed, height, weight, etc., some variables such as egoism, creativity, happiness, and religiosity and comfort, they are not single measured entities and they are called as construct. Okay, for example, if we talk about let's say motivation, or we talk about perception, or we talk about you can say happiness. Okay, now all these things cannot be measured through a single item. Okay, you cannot ask anybody, are you happy, or are you motivated? So there are different factors, there are different variables which can be joined to form a construct. Okay, for example, let's say if you are asked, let's say if I'm doing a survey of job motivation in a particular company, let's say IT company or IT sector or FMCG sector, or let's say automobile sector. So there are certain parameters of happiness. Okay, for example, if I talk about the employees of MIT University, so having a weekend off is a very important aspect of happiness. Okay, having Saturday, Sunday off is a very important aspect of happiness. So not only just the increments or salaries, but there are other certain parameters also which are important. Similarly, if you ask from a child or a student who is studying in, let's say, a graduation course, getting a lecture off is a very good motivation for him. Okay, I have an off, so I will go around and play. Okay, but and parallelly, there are other certain motivation factor also. Okay, getting good marks is also a good factor for. So these motivational factors are different for different people, and when you are measuring this particular motivation factor for a set of people, okay, when you are doing a research or you are collecting data, so when you are doing that kind of research or you're collecting, then you have to capture this particular emotion of motivation through different constructions, through different variables. Okay, so that is the difference between the construct and the variables. So when you are dealing with the factor analysis, you will also get possibility, or you also basically understand how to frame construct out of the different variables. So this also helps in joining the different variables to form a construct. Okay, so these constructs are then derived from the measured of other directly observable variables. So when you are measuring certain directly observable variables, so they are basically joined using the factor analysis to form the construct. Okay, so this is what the concept of So constructs are usually defined as the unobservable latent variables. For example, motivation, love, hate, care, altruism, anxiety, worry, stress, product quality, so on and so forth. Okay. Now, quality is again a very important construct. Okay. Quality has different definition for different people. Okay. So, again, when you are measuring the quality of a particular product in a company, then it has different parameters on the basis of which you can gauge them and finally form the construct of that particular. So you can form this quality as a construct. Now, factor analysis measures numerous observable constructs by measuring its underlying dimensions. So, what are the dimensions of a particular construct? Okay, now there once I have one I have discussed what are the what is the meaning of the term construct and how are these constructs measured or made. Okay, next second thing is how are the dimensionality of this particular construct measured. Okay, what is the meaning of the term dimensions? Yes, anybody, can you explain what is the meaning of the term dimensions of a construct?
Some aspects, sir.
Hmm?
Aspects.
So measurements.
What kind of aspects?
The relevant issues which are underlying that phenomenon.
The aspects related to some characteristic of features to be assessed
Okay,
during the
like
evaluation.
dimensionality of constructs. Like, can you explain a little more? You're on right track.
So, like we have an object and we are into getting the length, depth, or width of that particular maybe area or
Okay.
Like sir, credibility, dependability.
and
Well, like, sir, in case of sustainability, we say that there are three dimensions: social
Uh,
dimensions, environmental dimensions, and economic dimensions. So
Okay.
these are
like
basically
we do
underlying
we
issues
do
which describe
reviews.
that construct.
Yes, you're right. Absolutely right. So, as you rightly said, the dimensions of this particular concept of sustainability has economic and other two concepts. So, basically, using those two constructs or those three dimensions of a particular construct, you can measure that particular construct. Okay, and it is very important for us to understand that when you are measuring a particular construct or you are basically looking into the dimensions of the particular construct, it has to be basically done in a completeness. Okay, you cannot just measure. That is why whenever you are making a questionnaire, you cannot just ask single question and measure a particular variable or a construct. Okay, for example, let's say if I am asking you whether you had lunch few minutes, few, let's say in an hour back, you had a lunch, and how was the lunch? What is the quality of your lunch, or did you like that particular lunch? So you said yes, but maybe when you are doing a research, we should also give the, you can say, benefit of ignorance to the respondent, because he or she may have not heard your question properly or have ignored your question and not answered properly. So therefore, we basically ask 2, 3, 4 different kinds of questions, or just by rotating or changing the language of the question, so that we are very clear and we are very sure what we are trying to ask is being responded by the respondent properly. Okay, so we measure the dimensions of a particular variable very carefully using this particular concept of factor analysis. Okay, so factor analysis measure numerous observable constructs by measuring its underlying dimensions. The identification of such underlying dimensions or factors simplifies the understanding and description of a complex constructs. So it helps us in understanding, or it helps us in basically developing the understanding of how these constructs are made, which are specifically complex in nature. Okay, for example, when you talk about there is a construct called as service quality of a particular service. Okay, so when we are measuring the service quality, so there is a full-fledged you can say a scale on that, which is called a Serval scale. I think most of you must be under knowing that particular scale. It is called as ServQual scale, which basically is a service quality scale. So when you are measuring the service quality of a particular service, so there are 5-6 dimensions of that particular scale which we have to understand, of that particular service which we have to understand, and based on that we have to take decision whether the service which we are getting is of quality or of under quality. Okay, so this is some of the important things or characteristics of undertaking this particular concept of factor analysis. So the assumption of factor analysis is that underlying dimensions or factors can be used to explain the complex phenomena. So of course, the baseline is that we have to understand, or we have to basically we are trying to understand the complex phenomena or difficult phenomena, and these phenomena can be understood by you can say different factors, and these factors are reduced so that we can control these phenomena also, because ultimately the only thing which we are working over here is not understanding the these phenomena. We also want to control these phenomena. Okay, so whenever you are doing any kind of exploratory study, for example, let's say you are exploring the factors which are responsible for let's say particular phenomena. Okay, so most of the time the experts in the DRC or experts in the committee, they will tell you that okay, do not stop here, you also do the confirmatory test by let's say regression. Okay, so regression or SEM can be used, structure equation modeling can be used to do the confirmatory test on the factors which you have drawn. So what will this confirmatory test tell you? So let's say there are 5 factors that are leading to a particular phenomenon. Okay, so out of these 5 factors, we will understand that which particular factor is having the maximum, you can say, explanatory power. Okay, which is explaining. But how much to an extent, how much that is leading to that particular phenomena, that we will understand by using the confirmatory test of regression analysis. Okay, so regression analysis will give you beta values, which will tell you how much that particular variable is basically leading to the phenomena which is under the question. Okay, so that is why it is always recommended to use the confirmatory tests such as regression with the factor analysis. Okay, we cannot just stop by or just stop at the after completing or doing the factor analysis, right? So I will tomorrow, when we are doing the hands-on on how to do factor analysis, we will also understand the concept of the how we basically make factors out of the make the construct out of different factors, and using those factors, how will we basically doing the confirmatory test. Okay, so we will be doing some examples of confirmatory as well as exploratory using factor analysis and in SPSS. Okay, so observe. So I was talking about the understanding of factor analysis. So the assumption of factor analysis is that underlying dimensions can be explained, can be used to explain complex phenomena, and observe correlations between variables results from their sharing of factors. So there are different factors which are there, and those factors which are having a good amount of correlation, okay, they will be joined by the factor analysis and they will be formed a construct. Okay, and these construct will basically help you to explain your phenomenon. So for example, correlations between a person's test score might be linked to shared factors such as general intelligence, critical thinking, reasoning skills, reading comprehension, etc. Okay, so all these things can basically be joined and we can call it as a single particular construct. Okay, so this is what. So next is, what are the ingredients of good factor analysis? Okay, so ingredients of good factor analysis solution. So a major goal of factor analysis is to represent relationship among set of variables parsimoniously. It's a very important word over here, yet keeping factors meaningful. Okay, so the bottom line over here is that we have to basically keep all the number of factors parsimonious. Okay, the number of factors cannot be very high, and besides that, we also have to take that these factors should be meaningful. We cannot just join factors or do random factor analysis, because see, ultimately, if you understand this particular tool of SPSS, is just a, you can say, garbage in, garbage out, some sort of a thing. So you input certain numbers and you will get certain response. But it is not important, or it is not always important, that these results are absolutely true to its value. Okay, it has to be logically defined, and it has to be logically understood whether these answers are correct or not. Okay, so that is also very important, and that is the role of the researcher. Okay, so the logic and the reason and the meaning of all these factors, these variables, as well as the construct, have to be very carefully defined in the factor analysis. Okay, for example, if let's say I was reading a particular book where there was a description on you can say there was a description of regression analysis, and it was said that there was a study which was going on, and somebody just found out a relationship between the height of a person and the length of the shoes. Okay, now when you do a regression analysis, there will be some analysis, or there will be some result of this particular you can say combination, or this particular causal relationship. But in actual, there is no such a relationship, or there is no scientific logic of this kind of relationship. So in the end, what the research will lead to is spurious result. Okay, so we as a researcher, it is our duty to understand the logic, and we have to basically define the constructs very carefully. Now, how are these constructs formed? We will discuss this in detail. But if you ask me in brief, I will tell you very easily that the different number of factors. Let's say when you are doing a study and you realized, or you basically found out of the literature view, that there are, let's say, 24 factors or 23 factors which are leading to, let's say, employment, or you can leading to a student being selection in a company, or leading to customer satisfaction, or leading to you can say good quality service of a hotel. Okay, so all these are different situations, or these are different studies which are conducted in social sciences, which basically look into the numerous factors which are leading to to these phenomena. Okay, now when you are doing these studies, these kind of studies, you will find n number of variables, because different people doing research, they have done a lot of research on these aspects, and in the area of your study, and they have undermined, or they have understood that there are certain variables. So most of the researchers, what they do, they will prepare all the list of those factors which are basically responsible, because it is difficult for them to realize or to differentiate between important factors and unimportant factors. So gradually, when you start growing and you keep on doing research, after writing some 5, 7, 10 good papers on your areas which are published in good journals, so you basically come to know or realize that which particular you can say variables or construct are giving you good R-square value. Okay, for example, if I talk about my area, as I told you that I am working in the area of technology adoption. Now, whenever you take a particular model, which is called as technology adoption model, TAM model, so there is a common comment by most of the journal reviewers, that this kind of paper will not be accepted by this journal, or we will not be accepting this model in your paper, even if it is extended, or even if it is added by another model, another construct. Why? Because the basic R-square value of this particular model is very low. Okay, the explanatory power of this particular model is very low. So they all recommend higher or advanced models in this particular domain of technology adoption. So what my point over here is, or what point I'm trying to make over here is, that although we have this particular software of factor of SPSS, which will be used for doing SPSS, but just entering the data and getting out the results does not mean that you have got the correct result. Their relationship with the environment, their relationship with your study, and their relationship among each other is also very, very important, which you have to which you, as a researcher, you have to maintain. Is it clear? Am I going too fast, or is it fine?
Fine, sir. It's okay.
And I hope you are all with me. Anybody who's not able to comprehend?
Fine.
Hello? Okay. So I'll continue further. So a good factor analysis is both simple as well as interpretable. So when you are interpreting the factor analysis, so you have to be careful, as I discussed, and these interpretations are basically the will help you to get suitable results of your studies, as well as it will help you to develop good research papers in your area. Okay. Now, application of factor analysis extended. So this workshop will basically examine three common applications of factor analysis. So first one is defining the indicators of the construct. So of course, the constructs and the indicators are very important. Okay, and this will help us in getting these indicators. Second is defining the dimensions for an existing measure. Okay, so how the dimensions are defined, we will also look, and selecting items or scale to be included in the measure. Okay, now the third point is actually not done through factor analysis. This is done through literature review. But yes, the results which you get from the factor analysis will help you to understand that whether a particular item is to be included in the factor analysis or not. Okay, now since you have already included it in the factor analysis, you have taken it and you get the considered it in the data and done the analysis on this. So there is no point of removing that particular data. But yes, if the factor loading of that particular variable is low, then we will not use or will not basically keep that particular factor or item in our model. Okay, so that is the meaning of selecting a particular item or scale to the measure. Okay, so the applications of factor analysis, defining the indicators of the construct. So ideally, three or more measures should be chosen to represent each of the construct of the interest. The choice of measures should be as much as possible be guided by theory, previously research, and logic. Okay, so when you are doing a particular research or you're framing the questionnaire of your study, then generally what happens is we try to keep three or more items on of a particular on a particular measure. Okay, for measuring a particular variable. So why do we keep three variables, three or more than three variables? Can anybody explain that? Yes, Vaishali, can you explain me that?
Sir, to analyze the effect, I guess.
The how can we analyze the effect with one variable?
No, that is why three variables are chosen so that easily comparable
No, I'm not
effect
talking
can be.
about variable. I'm talking about three. See, ideally three or more measures. When you are talking about measures, it means you measure a particular variable through items. Okay, so I'm
Mhm.
talking about the items of the construct. So why should the items of the construct be more than three? Three or more than three?
Sir, for comparative study, maybe.
Okay, anyone else would like to try?
Sir, is it for objective results, sir?
Is it for?
Objective results?
What is the meaning of objective results?
Rational choice
Okay,
for
please explain.
rationality.
Okay, for rationality. So you mean to say if you are choosing less than one, then it may not be rational, right?
No, 1-to-1, there is no reduction, no, sir.
Okay,
If there is only one variable for one factor, then there is no reduction as such. So at least three will be better rather than two. So to
okay.
explain,
What will happen if we are having two variables or two measurements or two you can say items?
sir, in case there are two variables and one variable goes along with other variable other factor also during loading, then it can create confusion. So if there are more than two, then we can decide, okay, one is going to one is shared by two factors. So at least there are two factors which are loaded on a single factor. So I think that may be the logic.
Okay, okay. Partially you are right, because the answer to this question can be, or the point which can negate this logic is that we can also suppress the loadings of the factors which are less than 0.5. Okay,
Yes,
so
sir.
when
Yes,
you are
sir.
doing the factor analysis, there is an option where you can suppress the factors which are having loading of less than 0.1, 0.2, 0.5 till 0.7. Okay, so if the load factor loading is low, we can suppress that particular variable. So that can be taken care of. But when I'm asking when we are getting the questionnaire filled, or when we are making the, or we are basically trying to make the questionnaire. So in that particular questionnaire, we usually have 3 items per variable. Okay, or more than 3 items per variable. So what is the reason for that? Why can't we have 1 or 2 or 4 or 5? I mean, we can have more 4 or 5, but why not 1 or 2? So let's say I am asking you about the review of a movie, okay, or I'm asking you the review of a food item, or I'm asking you the review of a service. Okay, so when I'm asking you such review, if I'm asking you one question, you may or may not answer that particular question, or you not be the respondent is not attentive while answering the question, or he or she has not understood the question properly. Okay, and if you ask 2 questions, or you have basically take 2 measures, then you can there can be a confusion, because this scale can be entirely opposite also. So let's say if I ask you, how did you or did you like this movie Drishyam 2? Okay, so one point of time you will say, sir, one on the scale of 1 to 5. On one point you can say 1, and the other point you can say 4. Okay, or you can say 5. Now, as a researcher, it is confusing for me to understand what is your view, because ultimately, when you are using this Likert scale or 5-point scale, 5-point Likert scale or anything, you are basically trying to convert your qualitative uh, uh, conditions into quantitative conditions. Okay, so that you can measure them, and after measuring them, you can derive certain solid analysis out of this particular data collection. Okay, so let's say if I have asked 2 questions, so 2 questions can be one towards positive and one towards negative. So the 3 questions, if the third question is asked, that particular may be positive or negative. So there will be 2 questions out of 3 which are either positive or either negative. In that
Yes,
particular
sir, that
situation,
was my answer at the first place. Ki two items in a variable can create a tie, but
yes,
the
yes,
third one can give
will
a
that, right,
optimum.
absolutely, absolutely.
That is
So
why
that,
comparative study.
yes, yes, absolutely. So that is why we basically keep a third option. Now there can be a question to that, sir, that if we take if we are taking third question, 3 sorry items, then one can be positive, one can be negative, and one can be neutral also. Okay, let's say on the third statement, somebody marked 3 on the scale of 1 to 5, then there will again be a state of question mark. In that situation, what will you do? Yes,
We'll
madam.
create one more item.
Huh?
We'll create one more item under the variable, 4 items in a variable.
Again, what about them?
Ask another question.
No, in that particular case,
Add the
you reject,
dimension.
you
Add the
reject that
dimension.
particular response.
Sir, by adding some more dimensions.
No, I'm coming to that. I'm coming to some more dimensions. But here, if you have a questionnaire, and in that questionnaire you have asked 3 items, or you have taken 3 measurements of a particular scale, then if one is positive, the other one is negative, okay, and the third one is neutral, it means that the respondent was not in a good sense of mind to answer your question. Okay, because there is a very low chance that a particular uh, individual will not understand this question, or he is not ready to give answer, or he is not basically find it comfortable to answer. Okay, so these three under these 3 situations, we will reject that particular questionnaire response. Okay, now another problem can be, why can't we keep 4 questions? Okay, now in 4 questions, again in even number of questions, there can be a problem of half negative and half positive. Okay, so that is why we have framed 4 questions. Now, if you look into some more advanced research techniques, for example, if you go for SEM, okay, structure equation modeling, or PLSM, smart PLSM. So in those conditions, we have to keep a minimum of 5 response, 5 measures or 5 indicators of a particular variable. Now, why 5? Because sometimes what happens is that there are certain cross loadings, or there are certain times some items which are not loaded also properly. So when you are basically checking the minimum possibility or minimum conditions of doing SEM, then that particular test will not pass and the results will not come properly. Okay, so we need to keep more than 3 or 4. So to some extent, people keep 5 items on a particular question. Okay, is that clear?
Yes, sir.
Yes. Any other question? Any discussion on this? Okay. Next is application of factor analysis defining dimensions for an existing measure. So in this case, the variables to be analyzed are chosen by the initial researcher and not the person conducting the research. So when you are defining the dimensions of the existing measure, there are certain times what happens that there is someone who is doing the analysis and somebody who has done the prepared the questionnaire. So these two people will have different thought on the dimension. Okay, so it is very important to define the dimensions very clearly, and so that the factor analysis can be performed properly. So the analysis is performed on the predetermined set of items or scale, and the results of factor analysis may not be always be satisfactory. The items or the scales may have poor indicators of constructs, and there may be too few items or scales to be to represent each underlying dimension. So as I was discussing that not every time the factor analysis will give you a good result or a desired result or an expected outcome. Okay, so sometimes there are possibilities that you do not get the responses. Okay, so there are certain ways and means to check that, but ultimately it will be more dependent on the type of literature review which you have done and the kind of literature you have done. If you have not done extensive literature review, then the kind of questionnaire you are preparing, the variables which you are identifying, there will be a lot of similarity between the variables. Okay, and these similarity of variables will not give you a proper result out of the factor analysis, because ultimately this particular data reduction technique have certain you can say programs which are working at the back end, and these programs will basically try to reduce the factors on the basis of correlation. And if the correlations in the factors are not existing properly, the outcome of the factor analysis will be poor. Okay, and it will not be appropriate. Okay, so therefore it is very important to understand the dimensions properly and to make the dimensions and make the questionnaire very properly. Okay, because it will just take 5 minutes for you to enter the data. Okay, or copy paste the data from the Excel and run commands next, and you will be able to get some outcome of the factor. But ultimately, is that outcome usable, and is it what we are trying to achieve? So these factors are, or these two things are very important. Okay. So when you're talking about the steps of the factor analysis or the correlation matrix, so there are certain steps which are involved. Okay, so we will be discussing these steps today, and we will be implementing these steps tomorrow in the class, so that we actually understand how the factors can be withdrawn. Okay, so the first is the correlation matrix. So we generate a correlation matrix of all the variables, identify the variables not related to other variables. If the correlation between variables are small, it is unlikely that they share common factors. Okay, so variables must be related to each other for the factor model to be appropriate. So when you are talking about the related variables, so related variable, now if they are too much related, that is also a problem. If they are not related at all, then that is also a problem. Okay, because if you have heard about the problem of multicollinearity. Okay, can anybody tell me what is the meaning of this term? Multicollinearity. Anyone heard of it? Yes, Mr. Sabir Singh, you are answering something?
Sir, I think it is related to one variable going towards more than one factor.
So it may be the perfect relationship between the variables, or like
Perfect relationship between the variables. Okay, what can you explain it in bit detail?
um, like a relationship between a variable which is towards positive effect.
Okay.
Sir, a variable, if it is found to correlate highly with more than one factors, then it can lead to some confusion. So I think that is the concept of multicollinearity.
Yes, most of it is right. Let's say, I'll give you an example. Whenever we are doing regression analysis, this problem of multicollinearity we can see very prominently there. So when you see this particular problem of multicollinearity, you will get a very high regression. Okay, the R square value will be very high. So let's say if you get R square value 9.8 or 98%, 97%. Okay, so this much high there is a very low possibility or bleak possibility of getting such a high R square value. Okay, so in case you are getting a very high R square value, then that is a problem. Getting too high and getting too low an R square value is both a problem for the researcher, because if you are getting very high research R square value, it means that your dependent variables have been very highly explained by the independent variables. Okay, which is not possible in the material world, in the practical world. Okay, so it is a problem. So that is basically a problem of multicollinearity. So similarly, if we are having a problem of very high correlation, okay, among the factors, that is also not very good, because ultimately if the correlation is very high, how are they differentiated as a factor? Okay, so we have to understand that why are you taken them as two different factors if they are so highly correlated? So those two factors should not be very highly correlated. And similarly, if the correlation is very low, then what will happen?
It will show that there is no relation between two factors, or a very less relation. Then how can they be?
Exactly. You will not get any, basically, you will not be able to derive factors out of it. Okay, and if you're not able to derive factors, see, factors are derived out of the commonality between the variables. If there is something common between two or three variables, they will combine it. This factor analysis will combine it to form a one construct, right? So if you are, if this,
Between
so if
variables.
there is no commonality, or the quantity of, or the quantum of commonality in the
Is so high.
variables are very low, yes. So this will not lead to a proper results of factor analysis. Okay, so think of the correlations in the absolute value. Okay, so this is what they are trying to say. So when you are saying positive relationship or negative relationship, so that will not matter much. But yes, if the correlation is very high, it may be positively high or it may be very negatively high. Again, this is a problem. Okay, so the correlation coefficient greater than 0.3 in the absolute values are indicative of acceptable correlation. तो अगर आपके जो correlations हैं वो 0.3 से ऊपर आ रहे हैं, so that is a good enough factor for that's a good enough reason for undertaking factor analysis. Okay, so examine visually the appropriate of the factor model. So आपको basically when you are doing the factor analysis, you will be able to visualize, or you will be able to understand looking at the factor loadings, that which all factors will combine together to form the you can say constructs. Okay, so this is the first step in the process of factor analysis, right? So how do we check this? So there is a test which is called as Bartlett test of sphericity. Okay, so this test is used or this is used to test the hypothesis. The correlation matrix is an identity matrix. So just to give me a minute. Hello. Yeah, I'm sorry for the inconvenience. So I was talking about this particular Bartlett test of scarcity. So we were talking about how we can basically test this or how can we remove this. So we can conduct this particular test, and this test will help us in understanding whether the correlation matrix is an identity matrix or not. Okay, so what is identity matrix? So basically, identity matrix is a matrix which is having one at the diagonal and all the non-diagonal items are zero. Okay, so let's say a 3 by 3 matrix or 4 by 4 matrix. So in that particular 4 by 4 matrix, all diagonal items will be one and non-diagonal items will be zero. So only those kind of matrix can be, or you can say the correlation matrix can be proceeded for factor analysis. Okay, so this particular sphericity test is to be performed by the researcher. Okay, now what works at the back end of this particular, so this is about that. You don't have to understand what all those what are working at the back of the system or the SPSS. You just have to understand that when we apply this particular Bartlett test or Cronbach test alpha or all the other tests which are there, there is a specific value which is basically recommended by the major researchers or the developers of all these programs. Okay, so let's say if they say that the Bartlett test of 0.5 is a good test or Bartlett value of 0.7 is good. So we have to understand that this particular test will be cleared only and only if we pass that particular you can say minimum level. Okay, so if the value of the test statistics of for sphericity is large and associated significant level is small, it is unlikely that the population correlation matrix is an identity matrix. So we have to ensure that we are the metrics which we are using or the correlation matrix which we are undertaking is an identity matrix. If the hypothesis that the population correlation matrix is an identity cannot be rejected because the observed significance level is large, the use of factor model should be reconsidered. So again, if the matrix which we are using is a non-identity matrix or it is not getting the minimum threshold value, we have to reconsider whether we are using factor analysis is correct or we have to use any other method for doing the for basically doing our analysis. Okay, so under certain situations we cannot use these tests or these you can say factor analysis as a tool. Then next is KMO or the Kaiser-Meyer Olkin tool, which basically measures the sampling adequacy. So besides the identity metrics or besides the correlation metrics, we also have to understand that there is something called as sampling adequacy, which means that the number of samples which we have collected should be more than a certain limit, okay, or more than certain number. So we cannot consider or we cannot perform factor analysis if these factors are below that particular number. Okay, now to check this particular condition, we use or we do this particular KMO test. Okay, now what does this KMO test suggest? So when you consider or you do this particular test, the value of KMO more than 0.8 is considered KMO value to be higher. It means that the number of samples which we have collected are adequate or are good enough to conduct a factor analysis. Okay, whereas if this particular value is below 5, okay, 0.5, so it means that the number of samples are less and we cannot further conduct the factor analysis. So we have to stop there and increase the data for doing the factor analysis. Reasonably large values are needed for good factor analysis. Small KMO values indicate that the factor analysis of the variables may not be good idea. Okay, so we have to understand that if the adequacy of the test fails, okay, if this adequacy test fails, then it means that the number of samples which we have collected is not. See, what happens is, let's say we are collecting data, okay, and when you are collecting the data, there are many rules and regulations for data collection also. For example, if let's say you are having a questionnaire of 70 questions. Okay, so we assume that a particular person will not take more than 30 seconds per question to read it and respond it. Okay, now if the time we calculate the total time period based on the number of questions, and the complexity of the matter. So once you understand the time period or the approximate time period which is required for calculation, we basically what we try to do, we try to find out the, you can say, the approximate time to fill that questionnaire. Now, if the particular person is taking too high a time to measure or too low a time to measure, let's say if somebody is measuring, sorry, is filling your questionnaire in, let's say, just 2 minutes, okay, or somebody is taking 30 minutes to fill. So these two are two extreme values. Okay, so we, in that particular case, we have to reject those questionnaires. Okay, we have to reject those respondents. Now, when you are rejecting those respondents, and if this happens too frequently, then in that particular case, what happens is you will not be having enough data, or your sample will reduce. Okay, now in there are rules of collection of data in other advanced methods such as SCM. So if you, let's say you are collecting data through SCM, for SCM and applying this structural question modeling technique, you have to collect 5 times the total number of constructs you are having. So let's say you are having let's say 10 constructs. So 10 into 5 times you have to collect the data minimum, and maximum is 100, 10 times, sorry. So 5 times to 10 times the total number of constructs you have to collect the data. But there is no such rule in factor analysis. So the rule says that you have to conduct this test of KMO, and if this KMO value is more than 0.5 or 0. We are having is low. Okay. Step 2, factor extraction. Okay. Now we will start with the principal component analysis, or which we call as PCA factor analysis method, to calculate or to extract the factors out of the variable. Should I continue or should I break for 5 minutes, 10 minutes? What do you say?
Let us break, sir, for 5 to 7 minutes at least.
Break, sir, break.
Break.
Okay. कल आपने कितनी देर का ब्रेक किया था?
There was no break, sir. as such.
हाँ?
Yesterday there was no break, sir. We were
Yesterday there was no break.
No, day
no
before yesterday, on first day it was.
10
Okay.
minutes, 5 to 10 minutes.
Okay, let's break for 10 minutes. Okay, and
Yes,
then
sir.
we'll meet at around 3:30.
Yes, sir.
Okay.
Sir, okay, sir.
Okay. So yeah, we were talking about the KMO test of sample adequacy, and after that we were talking about the extraction of the factor. Now, factor extraction, which is the actual work which we are going to do, or which for which we are attending this workshop, is from this particular concept of principal component analysis, right? So we will basically try to the primary objective of this particular at this stage is to determine the factors. Initial decisions can be made here about the number of factors. Underlying a set of measured variables. So basically, we will use a method of scree plot and other methods to understand that how many total number of factors we can basically we require or we want to make, and using that particular principal component analysis method, we will basically estimate those initial factors. So the principal component analysis is the most commonly used extraction method. The factors extraction, the other factor extraction methods include maximum likelihood, principal axis factoring, alpha method, unweighted least square methods, generalized least square method, and image factoring. So there are other such other methods also which are used to do factor analysis, but the research and the literature in both, they suggest that principal component analysis method is the best possible method which will help you to get the most suitable results for your factor analysis. Besides them, there can be other method, for example, maximum likelihood method, MM method, or principal axis factoring method, etc., which are used. So here in this particular session, we will be doing principal component analysis only. And if you look into the various research papers which published papers based on factor analysis, you will find that majority of them, in fact, I have never seen any research paper in my entire career which is published other than principal component analysis factor analysis method. Okay, so we will be doing the same method. So in this particular method, or in principal components analysis, linear combinations of observed variables are formed. The first principal component is the combination of, that accounts for the largest amount of variance in the sample. So this particular method of principal component analysis is it basically makes the factor number one, and all these factors are listed based on their importance or their significance to the dependent variable. Okay, so the one or the number of factors which are combined to form one, the number of variables which are combined to form one construct or one factor is the number is at number one, which is the one which is having maximum number of variance, which is about, which is basically explaining the maximum amount of variance. The second principal component accounts for the next largest amount of variance, and it's uncorrelated with the first one. So naturally, the two you can say factors which have been formed, they are highly uncorrelated, and there is no common correlation between these two factors, and they are basically formed in order of importance and their contribution to the dependent variable. Okay, successive components explain progressively small portions of total sample variance, and all are uncorrelated with each other. Okay, abhi isme what we can do is that we can basically take up three or top four factors which are significantly contributing, and then we will understand that after third, fourth, or fifth, that depends upon the data collected and the kind of analysis you have done. So based on that, you will be able to understand that after third or fourth or fifth variable, the amount of explanation done by the variable in the whole process will reduce. Okay, so the variance of that particular factor will start going down, and we will understand that these variants are not contributing significantly, and therefore we will not consider those factors in the factor analysis. Okay. Now, next is that when we do or when we run the factor analysis to decide how many factors we need to represent, the data. We use two statistical. Other one is the scree plot. Okay, so when you talk about the eigenvalue, for all those eigenvalues which are more than one, we will consider the factor as significant. Okay, so if you can see the right hand side of this particular slide, I have shown you a figure. So this is one of the, you can say, output of the factor analysis. So once you have made, you have run the factor analysis using principal component analysis method. So this is the output which you will receive. So in the first column, it will tell you about the number of components which are there. So let's say 1, 2, 3, 4 till 10. So this particular factor analysis has basically used 10, you can say, variables. Okay, and using those, not sorry, variables, 10 items. Okay, so the summation or cumulative eigenvalue is explained by this particular is 100%, of course, in the last line. Okay, now we are talking about the variance. Now the variance explained by the eigenvalues is 3.046 in the first one, 1.801 in the second one, and 1.009 in the third one. Okay, I'm talking about the column number 2, which is talking about the total variance explained by the initial eigenvalues, right? Now below that, so it means that the component number 4, which talks about 0.934. Okay, so there is no, you can say, factor, or there is no such construct beside against this particular variable, against this particular eigenvalue. Okay, so we will be taking considering only these top 3 variables. Okay, now when you look into the second last column, extraction sum of squared loadings. So second last is percentage of variance. So as I was telling you in the previous slide, that the highest significant factor or highest explanatory variable will come at the top. So the first, you can say, construct, first factor or construct which is derived out of factor analysis is explaining 30%, 30.45% of the variance. Okay, in the dependent variable, and the second one is explaining the 18%, and third factor is explaining 10%. So in totality, if you talk about the cumulative variance explained, it is approximately 58.5, which is, you can say, 59%. So what this particular study says, that among the 10 variables or 10, you can say items which you have selected, this particular factor analysis have reduced the 10 you can say items to 3 factors. Okay, and these 3 factors have been able to explain 60% variance in the you can say the dependent variable. Okay, so this is how we interpret this particular you can say the analysis. Okay, the then a single variable, since the such variable is expected to have a variance of 1. So the all those factors which are having variance of less than 1, okay, so they are basically not combining with any of the other factor. So therefore, they are not eligible to become a variant. Okay, so they are not able to they are not eligible to become a construct in the factor analysis, and therefore we do not consider them as a construct. So the construct or the factor determined in this particular factor analysis are only 3. Okay, so this is one way of how you basically determine the total number of factors that have been reduced with the this particular technique of data reduction. Second method is that we basically plot a scree plot. Okay, we make the scree plot out of the eigenvalue, and out of that we see that the number of factors which are having the value more than 1. Again, same logic we will use. So the all those factors which are having a value more than 1 in this particular scree plot, we will consider for the as one of the factor in this factor analysis. The remaining factors we will leave. So basically, the remaining items are not joining together, and therefore they are not eligible to become a factor. Okay, so this the examination of scree plot provides a visual of the total variance associated with each factor. Okay, the steep slope shows the large factors, and the gradual trailing of or scree shows the rest of the factors, usually lower than the eigenvalue of 1. In choosing the number of factors in addition to the decision based on the conceptual and theoretical background. Now, what happens is that many a times the particular candidate does not perform this factor analysis properly. Okay, or the candidate does not take care of the minimum conditions which should be fulfilled. We have already discussed in the previous slide about sample adequacy, about the identity metrics, and all those factors, the Berlin test of spellicity, KMO test, etc. So if those factors are not satisfied, or the minimum conditions are not satisfied, then what will happen? The candidate or the researcher who is trying to do this particular research using factor analysis will not get a proper scree plot. Okay, so a scree plot will not be having more than 1 factor. So it will all be in the form of the gradual line, which is called as the scree. Okay, so if that is the case, it means that your factor analysis is not performed properly, and you can look into that particular the scree plot, and you can immediately get to know that my factor analysis is not actually done correctly. So you have to redo this factor analysis, and we have to do certain you can say modifications in the data. Okay, so doing certain modifications in the data will help you to provide the correct factor analysis, and you will be able to get proper factors out of the factor analysis. Okay, so these are some methods. Right. So next is steps in factor analysis, factor extraction. So now you see the factor loadings of all your factors. Okay, so you see in the next slide, we will, or this particular table, we see the factor loadings of all the factors which are there or which you have basically. So generally, this particular slide is showing all the factor loadings of the different items. But in general, when we do factor analysis, or books like Here and Black and good books on statistical analysis, they tell you that you should to get a clean factor analysis, it is always suggested to suppress the values of the factor loadings which are having the value of less than 0.5. Okay, now if you look into this particular table, you see that there are three important components or 3 factors which have been determined in the factor analysis. And if you look into these very carefully, factor 1, see the first item, second item, third item, they are having value of loading, factor loading of more than 0.5. The one which is at number 4 is having a low factor loading. Similarly, the one below the fifth item is also having a low factor loading. Then again, sixth one is having a higher factor loading of 0.7. Again, seventh one is good. Ninth is again low, 0.074. So when you suppress all these factor loadings, what will happen? You will get factor loadings only at the places where it is actually loaded. So if you look into the third last, this third last factor is loaded at component number 2 only. Okay, so at 1 and at number 3, the component load, the factor loading is low. Although at number 3 it is reasonably okay at 0.443, but still, if we suppress it, we will be getting very clean factor loading of this third last component in third last item in component 2. Okay, so this will help us in getting the component. Now, what is the meaning of this term factor loading? Can anyone explain? Anybody explain? What is factor loading?
It is correlation of the
Yes,
item
yes.
to the
So
factor.
correlation among what?
Correlation of the indicator or item to the.
Your volume
The
is very
factor.
low. You can raise the volume.
Sir, it is the correlation of the item to the factor, extracted factor.
Right, right. Yes, yes, absolutely. So the higher the correlation, the better the factor loading you will get. So if you check the factor loading of these, you can say different items on your factors, you will be able to see that, let's say if we talk about the second factor, okay, now the first factor loading is poor, okay, second is high. Now second factor is higher in first as well as second. So this particular item is having high factor loading on 1 as well as 2. Okay. Similarly, 3 is low, 4 is low, 5 is low, 6 is low, 7 is low, 8 is very high, 0.647, almost 6.5. Then low and then last is high. Okay, the last value is low in first and third, but it is high in second. So ideally, what should happen? That a particular factor should be loaded at only one factor. One item should be loaded at one factor. In case it is loading in 2 factors, then we have to consider it that way. Okay, but we should prefer, or we should try that we should get okay, one item should be high at one factor loading only. Is it clear, everybody? This is a very important concept.
Yes, sir.
Yes, all of you.
Yes, sir.
Yes, sir.
Are you sure, Nidhi, Mamta? I can see there are few people. All of you have understood this concept?
So your
Yes, sir.
screen.
Yes, sir.
Yes, somebody was saying.
So
You are
you're
not audible.
visible to me.
I'm not visible to you.
Screen. Shared content.
Screen is not.
Yeah, yes, sir.
My screen is not visible to anyone.
No, it is
It
visible,
is.
sir. It is visible.
It
It is visible, sir.
Okay, maybe you're the one who is
Maybe my
saying
network connection may be weak.
network issue. Right.
Mhm.
Yeah.
Understood.
So
Thank you,
okay, great. So I'll continue. So I was talking about this factor loading. So factor loading again, as Mr. Sadhbir rightly explained, that it is the quantum of the loading, or you can say correlation with of a particular item with a particular factor. So if a particular item is loaded or is basically correlated to more than one factor, it is not a good symptom. Okay, it is not a good symptom, or it is not a good factor analysis outcome. Okay, although getting such a result is not in our hand. Okay, but eventually when you develop this particular concept of factor analysis, or when you start doing, you will understand how to play with the data and how to remove all those items from the data which basically disturbs your analysis. Okay, and you will ultimately be getting the clean analysis. By clean analysis, I mean that one factor is one item is loaded at a single factor only with a value of more than 0.5. Okay, now what happens is that if your factor analysis is not clean, in that particular scenario, there is a possibility of rejection of your paper on the basis of this unclean analysis, or you can say there is a scope of better analysis, or they can say that you can collect more data and do reanalysis. Any kind of rejection you can face. Okay, so from the angle of publication also, and from the angle of doing your individual research also, because when you are doing this kind of research for industry, so this is not only applicable in academics, you can also do this research in the industry. So in industry, you don't want any kind of publication or any kind of, you can say, you don't need any such, you can say, stamping on your research work, but it is actually applicable in on the day-to-day basis in the industry. So there you need to get understand the concept and apply it very carefully. So there also you need clean regression. So you suppress the values and do other cleaning and modifications of the data so that you get a clean factor analysis, right? Next is factor rotation. Now, what is factor rotation? Factor rotation is basically when you try to understand or you try to correlate every single item with every single factor. Okay. Now, in this step, in this particular step, the factors are rotated. Now, what is the meaning? Unrotated factors are typically not very interpretable. Most factors are correlated with may some mistake is there with variables. Factors are rotated to make them more meaningful and easier to interpret. Each variable is associated with a minimal number of factors. So when you perform the factor analysis, you also do the rotation of the factors. Rotation of the factors means that each item is tried and checked with each factor, and we basically try to find out whether they are correlated with them or not. Okay, so if the correlation is good, okay, then again there you will get a factor loading. Okay, and if the correlation is bad, we will not get good factor loading. So actually, we should not get the factor loading with all the factors. The factor loading should come with only one factor. But we have to perform this test because if the correlation comes, it means that the selection of variables or the collection of data is not appropriate. In fact, it is not collection of data, it is the selection of variables. So again, it means that we have to go back to the literature view and we have to undermine or we have to determine the relationship between various factors and variables and see what all things can be done. Okay. So there are various methods to check this rotation. So the most popular method or doing this is the Varimax rotation. Okay. So beside Varimax, there are other 3-4 options, but they are orthogonal method is there, for example, then other methods are also there. But this is the best possible way for checking the rotation of each, you can say, item with the other factors. So Varimax is use orthogonal rotations yielding uncorrelated factors or components. Varimax attempts to minimize the number of variables that have high loadings on the factor. So it basically tries to minimize the number of loadings on each factor. So if the loading, as I was explaining, if the loading of one item on multiple factor is high, it means that there is a problem with the factor analysis. Okay. So besides this, there are other rotational methods such as Quatrimax or Equimax or Promax. So there are all different orthogonal or oblique methods of rotation. But again, the point is that when you follow Varimax method, so Varimax means maximum variations. Okay, so that is the full form of this method. So when you take the maximum variations or you basically vary it with every single factor, you will be able to get the best possible outcome in this factor analysis, right? Then there is something called as rotated factor matrix. Okay, so we form a rotated matrix also. The factor is interpreted or named by examining the largest values linking the factor to the measured variables in the rotated factor matrix. Now, what is the meaning of this rotation? Can anybody explain? Anybody who understand what is the meaning of rotation? Factor rotation. Yes, guys, why are you not speaking? All of you are not active, I think. Are you listening to what is being discussed?
Yes, sir.
Yes, so what is the meaning of this term rotation? What do we rotate?
items are rotated in such a manner that they cling together to, in such a way that they cling together to a particular factor.
Hello? Hello?
Sir, rotation means for me that the
Hmm.
items are rotated in such a manner that some uh, items uh, go with one particular factor.
So what does it give you?
So
When you
this,
do
this
the
kind of
factor, yes,
cluster formation of items, it gives
yes,
the number of factors.
okay. Just hold on. Yeah. So as he rightly pointed out, Mr. Sukhbir, that we basically check the rotation of all the items with all different items, so that we basically get the items and all the components very cleanly defined. Okay. So we consider this particular rotated matrix as the final matrix or the final component matrix, which basically helps us in determining the items which we have to join. Okay. See, ultimately, when you frame the factors. Now, when you see that, let's say in first item, the first item is loaded on only one factor one only, and it is not loading on factor 2 and 3. Whereas in second item is loaded only on factor 3. Okay, now what will you do after this? After you get all these, you will basically join, or you will basically merge all the values of the factor item 1 with item number 3 and item number 7, which is giving you 0.792. Okay, so when you join all these items, you will get a common item, which is basically your factor. Okay, and then when you get these three factors, you will be able to do any further analysis with these factors. Okay, so to do so properly and to find out the items very clearly and sorry, the factors very cleanly out of the variables, sorry, yes, out of these variables, you do the rotated factor. You need this particular matrix. Okay, and once this particular matrix is received, you will be able to capture the components or the factors very uh, particularly clearly. Next step is making the final decisions. Okay, so what is the meaning of the final decision? The final decision is about the number of factors to choose in the number to choose is the number of the factors for rotated solution. To choose all those factors which are highly interpretable, and all those factors which are not interpretable or having very low factor loadings, we will reject all those factors. To identify factors, so we will only select those you can say factors, or we will combine only those items which are having high factor loading. Now, plots of loading provide a visual for variable clusters. So once we see this particular scree plot, okay, we will be visually able to understand which all particular you can say factors will be framed or formed out of this particular factor analysis. So we interpret the factors according to the meaning of the variable. So if we are able to combine these factors well, now let's say we can say if you want to understand the personality traits of good leaders. Okay, now there are various factors which can be determined, or you can say various factors which are leading to good personality traits or good leaders in the community. So can anybody tell me what could be the factors? So let's say if we are having, we can say that there is a particular there is a good leader in the community or in the particular economy who is having, let's say, poor background, okay, or having a very humble background. Okay, so this can be one of the trait that, okay, yes, if somebody is coming from a very humble background, there is a very high chance that he or she knows the problems of the weaker section of the society, and he or she is able to work well for the society. But if somebody is not understanding the problems of the society, so he or she, so this can be one factor. but it is not always always possible or always true that a person who is coming from humble background will be a good leader. Okay, so we have to check the understanding, we have to check and understand the various factors or the various items which are combining together. Just a minute. Yeah, I'm sorry. So I was talking about the final decision. So we will basically be able to, you have to basically think and logically frame the different variables or different factors, which is basically derived through factor analysis. Okay, so again and again, I'm repeating this concept that the factor analysis will give you some factors. It will again join certain variables, but it is not necessary that those variables, joining of those variables will give you sensible factors. Okay, so we have to make final decisions based on our intelligence and literature review. That is important. So this decision should be guided by a priori conceptual brief about the number of factors from past research or theory, eigenvalues computed in step 2, and the relative interpretability of the rotator solutions computed in step number 3. So it is important that we basically look into the various components and analyze those responses and analyze the final outcome of the factor analysis and check what is going on. Okay, and if we get the good response, then only we will go ahead. Right, assumptions underlying the factor analysis. So there are certain kind of assumptions which are going on, which we take place which we have to consider while we are doing the factor analysis. Of course, when we were studying about the sample adequacy, we were talking about the rotational matrix, or we are talking about the identity matrix. They were the underlying factors or underlying, you can say, assumptions which were in, but these are also to be considered. The assumptions underlying factor analysis include: number one, the measured variables are linearly related to the factors plus error. So, can you tell me what is the relation? What is the meaning of this term linearity? Or how do you define a linear relationship?
So congruent.
One-to-one
Congruent.
relationships, linear, like relationship between X and Y.
I didn't get you.
For me, linear means one-to-one relationship,
Okay, so you can
like
say
like
that
between X and Y.
okay, okay. So generally linear equations or those equations which those are the equations or relationships are those relations in which increase in one component will lead to increase or decrease in the other component. Okay, so we have linear equations, quadratic equations. So all these equations have different meanings. So when you are considering the factor analysis, the equation which we are making is the linear equation. Now, what is the meaning? It means that the
Line.
line. So basically, you will have, let's say, a dependent variable, and there are few independent variables. So the sum of explanations given by the independent variables plus the error term should be equal to the dependent variable explanation of the dependent variable. Okay, so as we study in the regression, that there are four components which are leading to a particular phenomenon. Okay, so the x first first variable is contributing 20%, second is contributing 15%, third is contributing again 25%. So the sum of all those should be equal to the explainable part plus the error part, which is not explainable, which is should be equal to the dependent variable. Okay, so this particular linear regression has to be maintained. So the assumption is likely to be violated if the items limited response scales, 2 points response scales such as true or false or right or wrong items. Okay, if, for example, if let's say you have taken asked a question in terms of true, false or right, wrong. Okay, so in that particular case, you will not be able to convert your qualitative response to the quantitative response. Okay, so this is you can say this will be an error in your factor analysis. So you cannot do a factor analysis if the questions asked in your questionnaire is in binary mode. So the data should have the bivariate normal distribution for each pair of variables. Again, the data should be normally distributed. Okay. There is tomorrow when we will be doing the hands-on, I will show you how the data is to be checked before it is actually entered into the factor analysis sheet. Okay, so what happens is mostly when we are typing the data, let's say we have collected data through questionnaire. So if it is done online, okay, then there are very low chances of error, because in fact there will be no error, because this particular online method will not give you any scope of change. But if you are manually typing the error, there are very high chances that you double type same option. For example, you type 44 or 23. Okay. Now, in that particular case, if you are doing over typing or under typing, in that particular case, your average of that particular column will be disturbed. Okay. So it will be an outlier, and this will disturb the whole dynamics of your factor analysis. So to check that, what you do, you basically do the average of all the columns individually. Okay, so you check the average, and that average should always be below 5. Okay, why always below 5? Because you are considering the 5-point scale. If you are considering 7-point Likert scale, then it has to be less than 7. Okay, how can an average of numbers be more than the maximum value? Okay, so that is how you check. So you basically remove all the outliers, look into the data very carefully, analyze the response sheets, and then you can find out the outlier. So basically, this particular data should be it should be normally distributed. Can anybody tell me what are the other possibilities of data? What could be the skewed data in our data collection?
Same type of same kind of responses like 5,
Very
5.
good. Excellent. Let's say if all the responses given by a particular respondent, let's say a person is marking all 5, 5, 5, 5, 5, or 1, 1, 1, 1, 1, or most of the people are marking in the same way. It means that there is some problem with either the questionnaire, okay, or with the taking down or explaining the questionnaire, or some other problem may be there. Okay, so to handle that, we basically do the face validity, content validity of the questionnaire, and do the sample, the you can say sample survey. Okay, so all these things will basically help us to provide that. And once the data is collected, okay, so we do the basically the normality check of the data using this average method. Okay, so if the normality of all the columns are right, okay, and they are basically distributed properly, normally distributed, then we go ahead for the factor analysis. Okay. Next is observations are independent, and there is no dependency of one observation on other. The factor analysis model assumes that the variables are determined by the common factors and unique factors. All unique factors are assumed to be uncorrelated with each other and with the common factors. So there should be no correlation among the factors, and there should be highly uncorrelated. Okay, and there should be no common factor among the different factors which are identified. Naturally, what we are trying to get over here is that we are the different factors which are having no correlation, and we want to see that how we basically reduce our all the different items into few factors which are highly correlated. Okay, uncorrelated, sorry. So obtaining the factor analysis. So we are proceeding towards the actual doing of factor analysis. So this is how this particular sheet look like. Okay, although we'll do this in tomorrow's session. Okay, in detail, I will explain you all the different components of your sheet, and where to collect data from, how to make a file, how to save a file, and where to view your data, how to copy paste your data or extract your data, and all those things. Okay, but more or less, if you just want to keep it as a store, I will share this particular PPT with you. Here, the steps of factor analysis is given in detail. So this particular first slide is showing you the once you have saved all your data. So you go to this fourth tab, fifth tab, sorry, analyze. and under analysis, you go to dimension reduction. Okay, because we are doing the data reduction technique. So since factor analysis is a data reduction technique, so we go to dimension reduction, and out of this we do the first factor, which is factor. So we are doing the factor analysis. Okay, so once you select this, so before that we have to move the variables. Okay, so whichever variable, okay, whichever variable is to be considered for factor analysis, we will move those variables out of this particular box into the variable box. Okay, which will be used by selecting the option. So this first option, blue one, it is selected. So once we select this, and then we press this arrow, which is basically directing from left to column to the right column. Okay, so all those you can say items which will be which is basically in the left column, which we want to get factor analyzed, will be moved towards the right column. Okay, so we move variables or scale items to the variable box. So right hand side of the slide will basically tell you what you are or what we are trying to do, right? Next is factor extraction. When variables are in the variable box, select extraction. So then after this, we have to take, or we have to do certain selections. Okay, so certain selections which basically helps us in performing the factor analysis, and also take care of the assumptions. Okay, so we will be selecting certain options which will take care of the assumptions parallelly, and will also take care of the will also perform the factor analysis. So there are 5-6 options which are there at the right hand side uh, of the screen. If you see middle of the screen, there is a box, right? Is it visible, all of you?
Yes, sir.
Yes,
Visible.
Yes,
sir.
sir.
Yeah. So if you see this particular box, so we have basically entered our data to be factor analyzed from this box, which was earlier in blue color. Now it is white. So we have basically copied, or you can say moved, all our data or items from this box to the variable box. Okay. Now these box have become variable. No string value will be taken up as a variable in this particular block box. Okay, always remember that. So let's say if you are having string value like name, or you can say something like that, this will not be acceptable yet. Okay, we all know that factor analysis is done only on numbers. It cannot be done on string variables. Okay, so we'll not be able to take them. Now we go to the first option in the right hand side of the variable box, which is the descriptives. Okay, so once we press this particular descriptives, we will have the method. So which method we are using? We are using the principal component analysis method. So we have all discussed that why principal component method is the best method to use. Okay, and then we basically tick on certain options. Okay, now it is very important to understand why we are opting for these options only. Okay, so first is we need the correlation matrix. So we have to tick on correlation and not covariance. Okay, because the concept of factor analysis is on the background of correlation matrix. So tick on this. Then in display, right hand side of the block, we have unrotated factor solutions and scree plot. Always tick on these two. Scree plot is very important because it gives you the pictorial representation of your factors. Okay, so extract number one based on eigenvalues. So we have discussed that the eigenvalues which are more than one will only be considered as factors. Okay, and if you want to make the number of factors as fixed, then you can choose factor number 2 point, or you can say option number 2. Okay, so let's say I cannot work on more than 2 factors, or I cannot work on more than 3 factors. So in that particular case, you will choose second option. Okay, but it is always advised to allow the process, or allow the factor analysis to make its sole factors on the basis of the eigenvalues. Okay, so I will always choose the first option based on eigenvalue. Okay, so maximum iterations for convergence is 25. You can increase or decrease this convergence. If you increase the, you can say the number of iterations, it will give you better result. Okay, but you can 25 is also a good number. You cannot, you can simply not touch it and continue with it. Okay, so press continue, first button, and then it will take you to the next option. So next is methods. Okay, so we find what are the methods of rotation. Okay, so methods of rotation, we will select the none. Okay, we will select none here. Okay, we will then start. We will then continue with the next point. Okay, the
Sir,
next point is very important.
sir,
Hmm?
can't we select very much?
No, in
Instead
the
of
next step we
none?
will select very max. When we rotate the factors, no.
Okay, sir.
Now, yeah, when we are rotating the fact, we will then select. Okay. Hmm. So in the when you are rotating it, so we select the very max here. Okay. So during factor rotation, it decides on the number of factors based on the factor extraction phase that enter the desired number of factors by choosing either fixed number of factors or more than unknown number of factors. So here I have selected this very max method and display rotated solutions. Okay, we do not want the loading points. And again, in the last, the maximum iterations for the conversions we have kept as uh, uh, 25. Okay, so you can also decrease or reduce it. Okay, and further, further, if you look into the last, you will get the options. So in that particular option scale, you can select the scores to be of having more than value of more than 0.5. So all those values which is having with lesser number of values and as at more than less than, sorry, 0.5. So all those values or all those you can say factor loadings with value of less than 0.5 will be suppressed, and you will get only values which are having more than 0.5. Okay, so with this you will be able to get very clean factors, and there will be no overlapping of the factor loadings in the in the, you can say, factors. Okay, and with this you will be able to extract the factors which you are required for factor analysis. Okay, so at this point you are basically at a position where you will get the all different factors. Okay, now after you get the factors, okay, after you have you received the factor, you will see again all those slides with all those results which we have already seen. So there will be different component, there will be a particular matrix which will basically show you the total variance which we have seen here. Okay, so this kind of sheet you will get, which will show you total variance. So you will be getting the factors. Then again, there will be a scree plot, which will be giving you the visual position of your, and then you will start getting the component matrix, and you will also get the rotated component matrix. Okay, so the analysis and the understanding of those metrics we will study tomorrow when we actually go through the factor analysis and get the results. So tomorrow when we start with the class or the session, we will basically start with the data extraction, how we will basically extract the data, clean the data, and how we transfer it to the main sheet. Okay, our sheet, then we label our sheet. After labeling, we will do the factor analysis as I have discussed today. And finally, after the when we have received the factors which are desired factors are received, then we will basically try to perform the confirmatory test, which is the regression analysis. Is it clear?
Yes, sir.
Now, any doubt you are having, you can ask me.
Sir, regarding this relationship between item and factor, extracted
Mhm.
factor, do we need to
Mhm.
support that kind of relationship with literature review?
No, no, you are not. See, when you are writing the interpretation, okay, then you might require. Okay, but when you are getting the factor in the factor, you are not required to. It actually what happens is when you have extracted the factors, okay, you have framed the factors, then you write the interpretation part. Okay, that okay, this is the factor. So these items they combine to form this particular factor. Okay, now then later on when you are writing the discussion part of the thesis or discussion part of the research paper, there you can mention that okay, we have seen the similar kind of combinations or similar kind of you can see correlations in the in this particular paper, or you can cite some paper over there. Okay,
Okay,
but
sir.
as you don't need to talk about any kind of relationship in the regular, you can say, discussions or any
Oh, so before EFA, there is no need. So whatever
no, before EFA there is no.
so whatever indicators are there, they have those descriptions may need to be supported, may need support of theory.
Yes, later on you might require, yes.
Okay. No, before for selection of items itself.
Before selection, no. Before
For
selection,
selection of items of the for EFA, I think it is required. Theory part is required.
yes, of course, when you are selecting the item, then you, of course, you require it, because when the description of the question is made, okay, let's
Yes,
say I'm
sir.
talking about the thesis, or I'm talking about the research paper, I will have to discuss the research methods in that section. I have to tell about where have I picked my items from.
Okay, sir.
So that section I have to tell, and why I have specifically picked this particular variable, that is also needs to be required. For example, let's say I wrote a paper on technology adoption on rural women. Okay, so I selected a particular model, and based on that particular model, I added few variables to that model to improve its explanation. Okay, that paper was published in ABDCP category journal. It was a good journal, Taylor and Francis. So they asked me this particular question, that you have dropped one perform the exploratory study, but I have to give an explanation, and that is that has become the part of that paper, that why I have dropped that particular item in my because it is already an established scale, so I don't need to frame items in that particular scale. So I have to just give the explanation that why I have dropped that particular construct in my scale. Okay, so all these things are very important, and can be asked from the researcher by the reviewer at any point of time. Okay, so it's from in your first review, second review, in your research paper, at any point of time, it can be asked from them. Okay, so the logic of construct is very important and should be clear with it.
Thank you, sir. Understood.
Okay, any other question? The number of participants are 35. Just any questions so that we can close the session now? All of you are requested to please fill the attendance and feedback form. Have you received the feedback form?
Sure, sir. Sure.
Okay, I'll just request Monica, ma'am. Okay, once you do it, you can.
Sir, could you please once again about PCA? Is component analysis?
Could you please send?
Could you please explain once more about principal component analysis?
Yeah, sure. Why we are using principal component analysis?
Yes, sir. Yes, sir.
Okay. See, the term principal component analysis. Point is that we are trying to find out the principal factors or principal components which are leading to the dependent variable. Okay, so that is why we are using this particular method only. There are other methods also, like maximum likelihood method. See, if you have studied the concept of regression also, there are many different kinds of regression which we study, like least square or ordinary least square method is there, or maximum likelihood method is there. So many other, but by the principles of research and operations management. So these many researchers, they say that these are the best possible methods which gives you the best results in case of the social science, you can say, research. Okay, that is why we basically use only these methods for doing factor analysis or regression. Okay, the other methods are also not bad, but the best possible results you will get is through these methods only. Okay, so this factor analysis, once you do it with the principal component, so they will give you the main, you can say, items, or you can say main factors which will be leading to your dependent variables.
Okay, sir. Thank you, sir.
So just give me a minute. I will ask Monica ma'am about the.
And sir, this regarding rotation.
Okay.
I understand it only slightly, but what is the meaning of rotation of the variables as such? What is the background
See,
of this?
Okay, see rotation, when you are doing the rotation of the variables, what happens is that you are trying to understand the relationship of individual item with individual other item. Okay, in the initial case, we were trying to find out the rotation of one item with one factor. Okay, so we basically see there are two methods. One I have shared none, and the second I have done very max. Okay, in here also in the slides also you were asking that it should be very max. So in the first case it is none, the second is very max. So once at the first point of time when you are checking the rotation of the rotation of all the items, it is done with reference to the variables. Factors. Okay, the constructs which you have framed, which is made by the factor analysis. The second time it is done with the help of Verimax method with all the items. So it is checking the relationship with all the items, all items with all other items. Okay, so let's say there are 15 items. Okay, so first we will check the correlation of item 1 with item 2, 3, 4, 5, 6, 7, 8, 9 till 15. Then item 2 with 1, 3, 5, 6, 7, 8, 9, 10. Then item 3 with 1, 2, 4, 5, 6, 7, like that. Okay, so in this way, all the relationship of all the items are checked with other items. And based on this, basically, they are trying to check the factor loading. If the factor loading of two items are similar or higher, then we say that one particular item is loaded on two factors. Okay, so that is again, as I have discussed earlier also, that is not a good sign. So we basically have to check whether a particular item is loaded in one or more than one. Okay, that is why we do the factor loading.
Okay, sir. So in case a particular variable or indicator or item, it is loaded on two factors. So it is a case of multicollinearity, sir?
Yes, it is not considered good because it is multicollinear, right? So
Okay,
we
sir.
have to check this in factor answer. This is also one of the conditions. Okay, so it is always recommended that the a particular item should not be loaded at more than one factor.
Okay. Sir, what about communality? I understand that it should be above 0.5 for all indicators. It is okay,
Yes,
sir?
yes.
Correct, sir?
Yes, it is. I'll come to, I'll talk about communality tomorrow. I'll talk about Cronbach alpha also tomorrow. There are
Okay,
few
sir.
things which I have reserved for tomorrow also. Okay, not all the
Okay,
things
sir.
can be discussed, right?
Okay, sir. Okay, sir.
Although
It was nice,
already
sir.
I have overloaded the information, and since no other participant is speaking, I hope I have not overloaded it. Yes, other participants, may I, can you all switch on your cameras?
Yes,
Yes.
sir.
Yeah.
No, sir, it was very wonderful session, sir, today, because it is always a new thing. It brings a new kind of information when we attend such kind of high-profile advanced methods.
I hope it was useful for all of you.
Yes, sir.
Okay, great. So we'll meet tomorrow at 2 o'clock. Okay, and we'll do the hands-on on. So meanwhile, I have sent you a link of SPSS. So you can download that link and you can basically install it, run it, just press OK, and do not, you should not, you can say update that particular software. Okay, it's a cracked version. It is a version which is used for, you can say trial basis. So you can understand it, understand the factor analysis using SPSS on that trial mode and can use it for a month's period, probably later on also, but you are not supposed to share it. In fact, if you want to share also, you will not be able to share because the rights are with me, and it is only for the participants of this workshop, and you can use it for your research. Okay, and plus there are certain organizations which are having their advanced version in their own organizations. Okay, so this is a license-based tool. So there are organizations which have purchased the 10 license or 50 licenses. So you can use that also. Okay. So can download this, keep that ready, and you should have this this particular work file or this Excel file also should be ready so that we can copy paste the data, and then from after copy pasting the data, we'll start off with the analysis. Okay.
Yes, sir.
Understood, sir. So,
Okay, thank you guys. Just a minute, I'll check with the with Monica ma'am about the feedback form and the attendance.
Sir,
Yes.
I think they will be sharing it on WhatsApp also.
Is it done after the class?
Yes, sir, it is done
Both
after
ways.
the class.
Both ways.
Yes, sir. Mostly.
Okay, okay. Thank you so much. Then we'll meet tomorrow with the analysis. Okay.
Thank you, sir.
Sir, thank you, sir.
Yes, sir.
It was very wonderful, sir.
Thank
You're
you.
a very energetic speaker to say.
Thank you.
Yes.
Thank you so
Very knowledgeable as well.
much. Thank you. Thank you.
And
Thank you
fast
for the
also.
kind words.
And fast also.
Yeah, I tried to do it. Actually, I'm getting a lot of calls from the Pro VC sir, and I have to meet him regarding some research methodology coursework. So immediately after closing this, I'm running to his office.
नहीं सर,
Thank
अच्छा
you.
है आपका ह्यूमर वैल्यू भी बहुत अच्छा है. Keep on smiling, sir.
Thank you so much.
Thank
Thank
you,
you,
sir.
sir.
Okay, all of you
Thank you.
take care.
Thank you,
We'll
ma'am.
meet you tomorrow.
Thank you.
Thank you very much, sir.